Okay, thank you. Good afternoon, everybody. Thank you, Marianne, for inviting us to present some information about how we deal with cybersecurity when it comes to construction machinery. And we will try to give a overall presentation on that. And connected to the previous information, we recognize the topics and content. So we won't go into that detail, but I hope you can reconnect to our information because we feel that we share the same challenges. Sorry, that one. Shortly about myself, I'm leading the product cybersecurity development deployment at Volvo CE today, working with embedded system for over 20 years. So that's my role within the company today. Sheila?
Yes, I'm an industrial PhD student at MD and also I'm diagnostics engineer at the VCE.
Thank you. We're combining, so this is a team effort. We're trying this. Some words about Volvo Construction Equipment. We're part of Volvo Group, as you might already heard today. So different products are used on the road, and of course that's the trucks, and then we have the city, and at the site where we reside mostly, and of course we have marine applications. Showing this picture is to show that we can learn also from different applications within the Volvo Group. So we're not only dependent on our products, we can even utilize experience and sharing information from different applications. Marine might have different thoughts and ideas. We can bring it in together as a group and learn from that. So that's I think it's a good benefit and a strength from a Volvo Group perspective and a Volvo product. Looking at why we need to do it as a global manufacturer of construction equipment machineries, the world is evolving. We have heard it a lot today, and that more or less might drive new technology that imposes vulnerabilities and different solutions. And we might have different custom needs that creates that need. But you also have to think about regulations. Different regulation globally might impact what we do. And one example might be, for instance, we have China market. We sell products there also. That might be a different story than Europe. So we need to understand the whole world from a cybersecurity perspective also when we create solutions and what that imposes on our product. Because if we take this total global environment and we need to provide different kind of services, we need to understand what is applicable in what way depending on the market. And services might be, for instance, machine utilization. How can we be more efficient using our machines? And we have talked about it today, autonomous machines. In our case, that might help site efficiency. Our site owners might have multiple products and they want to make them autonomous. Then we have to maybe talk within our own products, but we also want to communicate with different brands. I will come to that a little bit later. Electrification is on the topic today also. We talk about sustainable environment. We are also looking into that from our products perspective, creating solutions that requires electrification. And I put this last, but it's not least, connectivity. I think Barbara mentioned a lot about the connected products. With this, you actually can connect talking with the infrastructure, you talk machine to machine and so forth. And then even you might have even controllability of a product. So what challenges does that bring when we do analysis and so forth? So if we combine everything here and try to figure out where does the product end up in this whole global market and providing these services or solutions, we might end up in this scenario. The product, modern product, will essentially be an IT infrastructure, but it's on wheels and 24/7 accessible. That's a huge challenge for us. And we more or less, I don't know if I dare to move this. We consider the product being part of the entire cybersecurity landscape now, because it's interacting with maybe back-end servers. It's interacting with the outside world. So we need to understand the interactions between the product and the back-end. I mentioned remote controllability. That might be a solution that is needed. So how do we secure the entire end-to-end solution from a security perspective? And I think previous speaker talked about information security. That is more or less the foundation for both IT part and product part. So how do we deal with this? This will be quite a challenge when we start looking at different connectivity interfaces, open source software that is residing within the product. I just made one picture just to highlight that it's easy picture, but it's a complex area from a product perspective. So how do we address this at Volvo CE? I don't go into the 1 million code example. I will start on a little bit higher holistic cybersecurity management perspective, because we feel that we need to address, we need to address all these areas to feel that we are confident when we do our solutions and understand the risks and possible vulnerabilities that we might introduce, but others might introduce. We have touched upon the suppliers. But shortly about these 9 boxes is that it starts with leadership priority. They have to acknowledge this is important. Then you get the momentum. Awareness and culture, I think Nasser talked about it a lot. We need to have awareness. All employees should know, feel that this is important, both for the business and of course for themselves when they are working with different solutions. Policy and governance is supporting the development activities. It might be agile or DevSecOps and so forth. So the organization is recognizing and monitoring it continuously. It will come later. But and the approach we have is risk-based. We will do risk-based. For instance, TARAS. We will perform TARAS to understand the threats and the risks. Security by design was mentioned earlier. That will be our approach, but why do design if we don't know the risk? Maybe it's too costly. So in that sense, we need to be good in TARAS to actually design it in a good way. Continuous risk management is monitoring the overall risks that might reside within the organization so that we keep track of them, because it might become a business risk at the end. So that is important to continuously informing and communicating within the organization. I think Nasser mentioned also about incident and crisis management, what we call it. Then that is really, really important, because then our customers are using our products. So we need to be swift and react really, really fast if we encounter an incident. So we need to have a good incident management system in place. External collaboration is suppliers. We heard about it just before this. Really important, because we need to understand what are they bringing into the product. And this is also collaboration. So it's good to have all kinds of collaboration when it comes to cybersecurity. And lastly, but not least, regulations and compliance. Today, our products don't have regulatory requirements, but I know the machine directive is under scrutiny. They are looking into it, and I would imagine it comes really fast, because the automotive industry has put R155. So I expect it to be ending up in our products also through the machine directive. Some words about, as I mentioned, we're part of Volvo Group. They are implementing the cybersecurity management system based on ISO ASAE 21434. So, of course, Volvo CE will utilize the findings, tools, and all the things that can benefit us when we create our products. So we follow the Volvo Group's intention with securing Volvo products if we now step up to a Volvo product level. So, and Sheila will present some high-level development strategies that we have.
Yes, yeah. Thank you, Jarmo. So far we have heard from Jarmo that the connectivity is delivering us very bigger benefits in the construction machinery in terms of higher productivity, lower cost, and most importantly, a safe work environment. So as manufacturers grow more dependently on internet connected technologies, the data security and the product cybersecurity become more critical than ever. So to overcome that, this is our holistic and systematic product cybersecurity development approach in order to reduce the cyber risk in the construction machines to the minimum level. It assures like security by applying 3 security principles: security for the entire system, that is from the individual ECU to the connected cloud backend, and the whole life cycle from the requirements to the vehicle phase out. And at the organization level that we seen earlier, like from security processes till the security governance. So these are closely aligned with the ISO SAE 21434 standard, as Volvo is establishing it soon. So in the design phase, we formulate the security objectives, perform TARAs, and from that we derive the security requirements and develop security concepts. So common design guidelines includes, for example, for embedded software, it will be integrity protection during the download, during the boot, and also during the execution. For the communication links, it could be authentication, encryption, and integrity verification. So here, security by design also includes onboard logging and offboard monitoring integration. So how to achieve and implement security? So it is planned to follow some secure coding techniques, static code analysis, code review, and formulate how to manage third-party open source software. So there are many standard tools available to perform these tasks, and securing hardware is also a very important factor to consider because we hear so much of attacks on hardware and chip level to extract the information from the firmware. In the testing phase, it is planned to do different kinds of security testing. The functional testing is to verify the correct implementation of the security measures. Vulnerability and fuzz testing are also for detecting known and unknown vulnerabilities. And the known vulnerabilities, what I mean is like scanning for open ports and verifying if known the vulnerabilities are patched or not. So unknown includes like fuzzing, where interfaces are exposed to unexpected inputs. Pen testing is for authorized simulated attacks on the system, which includes white box, black box, and gray box test methods. And last phase is the maintenance. So how the security is maintained throughout the product life cycle. We already agree that the vehicle's life cycle is more longer years compared to the IT products like a computer. So it is more important to have a security maintained throughout the machine operation by having some threat intelligence, intrusion detection systems, and correction for newly identified vulnerabilities, and incident response to organization by having the SOC and the incident response team, and the continuous risk review for the released products, and the security objects and the incident response. So can we go to the next slide, please? Yeah, to summarize, we have seen from earlier presentations of Stefan and Nasir, like what are all the challenges in automotive, and they are very true for construction machines too. And I will finally conclude with an overview of how our machines are different from other segments in terms of security. Since complexity is the worst enemy of security, we will experience also a lot of related cybersecurity risks and threats compared to standard passenger vehicles, because our machines will be more susceptible to cybersecurity threats, because it uses very complex and software-driven functionality. What I mean here is like we have more aftermarket options that the engine and the main components can customize and chosen by the customers. So there are lots of accessibility to the system and the software for easier integration for the aftermarket options, which leads to potential weaker points for cyber risk. So the machines also transfer and processes more data internally and externally via powerful long-distance LTE interface communications, for example, fleet management systems. Also in machines, we use a standardized SAE J1913 protocol, which is different from the regular CAN, where one has to reverse engineer the CAN messages on the real-time bus to understand the information, but in trucks and machines, it is just required to read the standard documents to understand the CAN data. And finally, the machines are operating like 24/7, as we seen earlier. And so it has to be connected all the time and also required to be monitored remotely, since it's not very feasible to take the machine to the workshop for fault tracing purposes. So hence we take like very serious machines to take care of our machine in an efficient way. And also we believe our customers rely on our products and services because of this. We need to make sure that we meet the challenges when it comes to cybersecurity. And I think I'm quite done. And we can, if you want to add anything.
Oh, well, I'm fine.